All right, welcome back to another math lesson. Remember, if you haven't done the exit ticket from the previous box, go ahead and pause the video now. Attempt these 4 problems on your own. Remember, these are all EOG-based questions. And then once you're ready and you attempted all 4 of these, go ahead and unpause the video and we will go over it together on the next slide. All right, going over number 1. Now, eventually we're trying to figure out what this expression is. But in order to do so, we got to figure out what x is first. So we have to solve this left side, find the value of x before then substituting it into that x over there. So when I'm looking at this problem, we see x minus 11 equals 16, or some number minus 11 equals or is the same as 16. That means that this x has to be more than 16. And since we're taking away 11 from it, we know that it's literally got to be 11 more than 16. We can solve this by taking the inverse of this operation. Remember, we got to get the x by itself. We got to isolate it. So we take the inverse of minus 11, which is plus 11. And in order to keep this equation balanced, what I do to one side, I got to do the other. So if I'm adding 11 over here, I got to add 11 over here as well. We know that minus 11 or negative 11 plus 11 cancels out. They zero out. There's 11 zero pairs. Drop down the variable, so x equals 16 plus 11 is going to be 27. Now, for my all-stars out there, they're going to take the time to actually check the work. Plug in 27 for x. Is 27 minus 11 16? Absolutely. We know that x is going to be 27. Now, know that 27 is going to be an answer choice. That's the trap answer. That's what they want you to choose to try and trick you. But that's not what it's asking. It's not asking for the value of x. It's asking what happens if you plug x into this expression. So now that we know that x is 27, we're just going to rewrite this expression. 2x means 2 times x. So that's 2 times 27 minus 10. Order of operations, we know that multiplication comes before subtraction. So 2 times 27 is 54. Drop the rest of the problem down. 54 minus 10 is going to give you a total of 44. So for number 1, she got 44. Number 2, a student earns $56.25 after working for 9 hours. How much money does this student earn per hour? This per hour lets us know this is a unit rate problem, which means we got to get it down to just 1 hour. Remember, there's no s there. So we're looking for something singular. Whenever there's a singular vocabulary word, we know it's unit rate. So whenever I say money, it's usually going to be money over everything. In this case, it's money being compared to hours. So our ticket is going to be money or dollar amount over the number of hours. Now we can plug in the values into the ticket to actually make our ratio, which is 56.25 for every 9 hours. Again, because it's unit rate, we got to get the hours down to 1. Hours is the denominator, so got to keep it as a denominator. To go from 9 to 1, to go from anything to 1, you just got to divide by itself. So 9 divided by 9 is 1. And 56.25, whatever the top and the bottom, divided by 9 gives us 6.25. Remember, just that numerator is going to be the answer. So you can say she makes, or he makes, $6.25 per hour. So your answer should have been 6.25 or $6.25 for that one. Number 3, a lot of mistakes here throughout the year. These number sentences get mixed up a lot whenever we see this less than. So you got to take a step back, ignore that mess up. Take a step back and ask yourself what it's actually asking. When something is less than something, just ask yourself a question. What's 1 less than 10? You know it's 9. What's 2 less than 8? You know it's 6. What's 8 less than 18? You know that's 10. So whenever something is in front of the less than, that's what's getting taken away. So the fact that it's 3 less than something else, we know we're taking away 3. So it's going to be something minus 3. Well, what are we taking it away from? Twice a number. Well, the word twice indicates a multiplication problem, so we're going to be multiplying something by 2. but we don't know what we're multiplying by. So a number is going to be a variable. Anything from A to Z. In this case, it's going to be n, so we write 2 times n, just 2n. So it should be 2n minus 3, which means that D is the right answer there. A is the trap answer, okay? A would be the difference of 3 and twice a number. But because it's 3 less than, we know that we got to take away 3. Last but not least, excuse me. A right triangle has a base that measures 5 inches. The hypotenuse of the triangle is 13. The height is 12. Determine the area. Well, it's important to note that the area of a triangle is 1/2 times base times height. Doesn't have hypotenuse in there at all. Now, a right triangle has a right angle, so it looks like this. This being the right angle. Anything that's opposite of the right angle is called the hypotenuse. Or just know that the hypotenuse is the slant. So the slant is 13. Remember, when you go to the doctor and they ask for your height, they don't ask you to slant over or slouch over. They ask you to stand up nice, straight, and tall. So this is height. Whatever is going straight up and down. Whatever forms the right angle is going to be used for the base and the height. So in this case, we're not using that 13. The 13 of the hypotenuse is here to trick you. What we are using is the base that is 5 and the height that is 12. So you just go ahead and plug this into your formula. 1/2 times the base, which is 5, times the height, which is 12. Well, 5 times 12 is 60, and half is 60. If you go ahead and plug this in, you get 30. And we know that the unit is inches, so it's 30 square inches, or 30 inches squared for that one. Hopefully you went 4 for 4 on that warm up. Moving on to the daily dose. This is calculator skills. Now, if you don't have a calculator, this is still feasible. However, it is a lot quicker if you do have a calculator. So whether you're using a phone, you will have a calculator if you're in class, but go ahead and attempt these. Go ahead and pause the video and attempt these on your own. All right, well, one way to attack this problem, I'm gonna do the long way first and show you the much quicker way with the calculator at the end. One way to attack it is to convert these into improper fractions. So we know we do this by kind of going clockwise. 7, it's the denominator times the whole number plus the numerator. So it would be 7 times 1, which is 7, plus 3, which is 10. And the denominator stays the same. This would be 10 over 7. Same process here. 8 times 1 is 8, plus 5 is 13, so that'd be 13 over 8. 5 times 1 plus 1, 5 is the same, so that'd be 6/5. 6 times 1 is 6, plus 2 is 8, so that would be 8 over 6. Now, in order to compare fractions, they all have to have the same denominator. So we would have to find the least common multiple of 7, 8, 5, and 6. That's going to take a lot of work, and if you actually work it out, which I'm not going to make you do because it takes forever, you'd find out that the least common multiple of each of these is going to be 840. So notice that all the fractions now have 840 as a denominator. So we'd have to figure out how many times each one of these denominators go into 840, and then you multiply that number by 10. I would just follow along here. I'm not going to make you do it because it takes way too much work. In order to figure out how many times 7 goes into 840, we would just divide it. So 840 divided by 7 gives us 120. So 10 times 120 gives us 1,200. So we have 1,200 over 840. Next one, 840 divided by 8 is 105. So we do 13 times 105, we get 1365. Next one, 5 goes into 840 168 times. So 6 times 168 gives us 1,008. And last but not least, 6 goes into 840 140 times. You multiply that by 8, we get 1120. So that was kind of a roundabout way to get our answer, but we know since we're answering which of the students ran the most laps, we're just looking for the greatest number. So which numerator is the greatest? We see that 1,365 is the most. So we know that Betty is going to be our answer choice. Now, a much quicker method is to just use your calculator and divide it out. If you have one of these calculators, we can type in 1 3/7 by doing 1, ABC 3, ABC 7, hit enter, and then hit second PRB, which is second FTD, which means fraction of decimal. And that gives us 1.428571429. Just do like the first 3 or 4 numbers. I would round it to 3. So we have 1.42, and since it's 85, I would say 1.429 approximately. Little squiggly means approximately. Or another way to do that, since you already have 10 sevens, you could do 10 divided by 7 and get the same answer. If I were to do that for 1 5/5, or excuse me, 1 5/8, or so it would be 1 ABC 5, ABC 8, and then second FTD. Or if you just type in 13, remember fraction bars mean division, so 13 divided by 8, we would get this one straight up equals 1.625. Next one, 1 ABC 5, or 6 divided by 5, we get 1.2. And remember, it's easiest if they all have the same number of values after the decimal, so if it's not the same, just add your zeros. So since there's 3 numbers after it, I'm gonna add 2 zeros. Last but not least, 1 2/6, or 8 divided by 6, we get 1.33333 repeated forever and ever. So I just write wrong 1.333. Answering the same question, which of the students ran the most laps? Well, obviously 1.625 is greater than the rest of them. Next being this number, and then Diane, and then Claire running the least. So either way you do it, Betty is running the most laps. All right, getting into our ratio stuff. I've done a few of these lessons already. Starting out easy. If you want to try it before me, go ahead. If you want to, you can go ahead and pause the video, or you can just follow along on the slide, that's fine. This is kind of the basic stuff. In a sample of soil, the ratio of oxygen to nitrogen is 4:3. So right here, with the word 2, that is our ticket. So we have oxygen to nitrogen. So since oxygen is first, that's gonna be my numerator over nitrogen. Here is our ticket. It's the ticket to get us in to solving the problem. So the ratio of oxygen to nitrogen is 4:3. Because 4 is first and oxygen was listed first, I know 4 is the oxygen, 3 is the nitrogen. When I'm reading it, it says there are 15 units of nitrogen. Well, nitrogen is the denominator, so I gotta put 15 on bottom. And now for the easy part, we just gotta figure out how many times 3 goes into 15. Well, 3 goes into 15 5 times, so what I do the top, do the bottom, and vice versa. So 4 times 5 is 20. Now it's important to remember, the answer is not 20 over 15. It's saying if there were 15 nitrogens, that means there would be this many oxygen, so there is 20 units of oxygen. So the number 1, the easy one, the basic one, you should get 20 units there. Again, if you want to try this one on your own, go ahead and pause it, try and beat me to it. If not, just follow along. A little more complex here. In an animal shelter, there are 5 dogs for every 3 cats. Which of the following could represent the ratio of dogs to cats? So again, dogs was listed first. Hopefully my board stops doing this. Dogs was listed first. We got dogs over cats. Not too far. We got dogs over cats. Okay? How many dogs? Well, it tells it right here. 5 dogs for every 3 cats. It says which of the following could be an equivalent, or which of the following could represent the ratio of dogs to cats. Basically looking for an equivalent ratio here. So what we can do is just kind of plug in all A, B, C, and D into equivalent fractions. So number 1 says 6 to 10. Well, if you look at my original ratio, 5 is greater than 3, so that means the numerator has always got to be greater than the denominator. 6 is not greater than 10. 5 doesn't go to 6 evenly. This one doesn't make sense at all. The answer cannot be A. If I'm looking at B, we have 12 to 20. Again, 5 doesn't go into 12 evenly, 3 doesn't go into 20 evenly, and really the biggest indicator, remember the numerator has to be greater than the denominator, so this B does not work as well. C, getting there, we have 30 over 50. 5 times 6 is 30. but 3 times 6 is not 50. We know it can't be that one. Again, we also know it wasn't right because the numerator was less than the denominator. Last but not least, looking at D, because it's the last answer choice, it's obviously got to be the right answer. But just to prove it, let's look at it. We have 90 over 54. Well, 5 goes into 90 18 times, so that means 3 times 18 has to be 54. In this case, it is. So this one works. So that means if there were 5 dogs for every 3 cats, that means there would be 90 dogs and 54 cats. Last but not least, a classroom has 3 boys for every 2 girls. Which of the following could represent the total number of students in the class? Well, if I'm going to make a ticket here, boys would be first, girls would be second, and it says 3 boys for every 2 girls. Well, the rest of the problem doesn't give me another number. So I can't plug in for boys or girls. But when I'm reading this, it's asking for the total number of students. So I'm going to solve this a different way. Instead of making a ticket, I'm going to make a little table. We have boys, girls, and the total amount. Well, I know there's 3 boys for every 2 girls. We got to fill in the total. Well, if there's 3 boys and 2 girls in all, how many students is that? You add them together, we get 5. Because it's the ratio, it's going to stay proportionate throughout. So that means I got to keep counting by 3 in the boys column, keep counting by 2s in the girls column. So this would be 3, 6, 9, 12, so on and so forth. This would be 2, 4, 6, 8, and since we're finding the total, we're just going to keep adding the boys and the girls together. 6 plus 4 is 10, 9 plus 6 is 15, 12 plus 8 is going to be 20. Well, if you noticed, with the boys, we kept counting by 3s. With the girls, we kept counting by 2s. So in the total, what do we count by? 5, 10, 15, 20. We're counting by 5s. So really, when it's asking for the total number, you can just find whatever that total is from the original ticket, 3 boys and 2 girls in all 5 students. So just find a multiple, which one is a multiple of 5. This would be 5, 10, 15, 20, 25, 30, 35, 40. In this case, 30 would be the answer, because 5, if we're counting by this number, does not go into 14, doesn't go to 24, does not go into 28. It does go into 30, so 30 could be a representation of this specific ratio. All right, based on those 3, go ahead and pause the video and try these on your own. Now, number 1, remember, it's okay to have a fraction within a fraction. So the 3/4 is going to be the numerator. It's not going to be 3 numerator, 4 denominator. It's going to be 3/4 over something. But at this point, go ahead and pause it. We'll go over it here in 1 second. I read number 1. John's using 3/4 cups of concentrate for every 15 gallons of water. How many cups of concentrate basically would be required if you use 45 gallons of water? Well, first of all, we're going to figure out our ticket. What is being compared here? Well, concentrate is being compared to water. You could write W, or if you're fancy, you know what water is good old H2O. So plug in our values here. How much concentrate was given to us in the original sentence or the original problem? 3/4. So 3/4 is going to be the numerator. We got a big fraction bar, so it's 3/4 over, well, 3/4 for every 15 gallons of water, so 15 goes on bottom. Last but not least, it says how many cups of concentrate would be used if 45 gallons of water was used. Well, since 45 is the number given to us, we got to figure out, is 45 going on top or bottom of the fraction? We know it's going to be the denominator because water is the denominator, it's got to stay there. So 45 is down here. Last but not least, figure out how many times 15 goes into 45. Well, 15, 30, 45, it goes in 3 times, so we've got to multiply by 3. One at the top to the bottom, vice versa. 3/4 times 3. If you got a calculator, go ahead and use it. Or no, if you don't have a calculator, know that multiplying by 3 is same as multiplying something by 3 over 1. Now you just go straight across. 3 times 3 is 9. 4 times 1 is 4, so your answer is going to be 9/4. And if you took it a step further, 9/4 is the same as 2 and 1/4, because 4 goes into 9 2 times. When it goes in twice, that gives us 8, so there's 1 left over. and the 4 stays the same. So if you get 9/4 or 2 1/4 cups of concentrate, that is the correct answer. Either one's acceptable. Number 2, Stacy can mow 2.5 acres in 3 hours. How many acres will she complete in a 12-hour workday? Well, the ticket, we're comparing acres to hours. So I'll just use A over H. If you want to write it out, that's fine. Plug in the correct values. How many acres? Well, we have 2.5 or 2.5 for every 3 hours. How many acres would be mowed in 12 hours? It's hours, so the 12 is going to be on bottom. Now the quick math, 3 goes into 12 4 times, so times 4 times 4, and 2.5 times 4 gives us 10. So in a 12-hour workday, which is a lot of hours, she works 12 hours, that means he or she is going to mow 10 acres. So we got 10 for number 2. Last but not least, number 3, in a lecture hall, the ratio of men to women is 4 to 6. Which of the following could represent the total number of students? So just like we did in the last one, it's asking for the total number. So I'm not going to make a ticket here. I'm just going to make just a column of men to women. Sorry about this. So we have men, women, and then the total amount. Well, in the ticket it tells us there are 4 men for every 6 women. So total 4 plus 6 is going to be 10. So again, we're looking for a multiple of 10. If you don't remember how to do this from the last slide, we're counting by 4s over here, so that'd be 8. Count by 6 over here, that'd be 12. And 8 plus 12 is 20. Count by 4s, you get 12 plus 18 is 30. And if you remember, since it's asking for the total, we got to look at this column. Basically counting by this number, so 10, 20, 30, 40, 50, 60, whatever one of these is a multiple of 10 is going to be our answer. We know that 10 does not go into 12 evenly, 24, it does go into 30, does not go into 46. So in this answer, or in this problem, the answer would be C, 30. All right, these are ratio problems that deal with units of measure. So the ticket is going to be at the end of the problem. If you think you can solve these on your own, go ahead and solve them. If not, or just go ahead and solve it, pause the video. If not, let's go over them together. So number 1, the green one. The screen on a new television measures 100 inches. About how many centimeters will this be? Or how many centimeters will the monitor measure? Sorry, I can't read. So the ticket is actually going to be given to us at the end of the problem here. We're comparing inches to centimeters. So my ticket, inches is first. We have inches over centimeters. Plug in the tickets at the end of the problem. It's 1 inch for every 2.5 centimeters. Going back to the first sentence, it says 100 inches. So I have inches as the numerator, so that means I put 100 as the numerator. And we know that 1 goes into 100 100 times. So we're multiplying each by 100. So 2.5 times 100 gives us 250. So if it was 100 inches, if the screen was 100 inches, that means it would also be 250 centimeters. Number 2, a typical road race. I don't know why I cannot speak today. Sorry. A typical road race is a total of 5 kilometers. About how many miles is the race if 1.5 kilometers equals 1 mile? 1 mile. So we have kilometers over miles. Go ahead and plug in the values. How many kilometers are given to us in the ticket? That's 1.5 for every 1. So we know that there's always going to be more kilometers than miles. In the problem, it gives us how many kilometers there are. This one's probably going to require a calculator because I don't know how many times 1.5 goes into 5, so I would work backwards and do 5 divided by 1.5, which gives me about 3.33 or 3 1/3. Remember the line indicates it's repeating, so if I'm multiplying the top by 3.33, do the same to the bottom. So we know that a 5 kilometer race, 1 times 3.33 is going to give us 3.33 approximately. So you'd say, remember the squiggly line means approximately. The answer is about 3.33 or 3 1/3 miles. So if you run a 5-kilometer race, aka a 5K, you're running 3 1/3 miles, or approximately 3.3 miles. Last but not least, at Best Buy, television weighs 12 kilograms. How many pounds would this be with this television weigh? So we have 1 kilogram equals 2.2 pounds. That's our ticket. We got kilograms over pounds, which is LBS. Plug in the corresponding values. We have 1 kilogram equals 2.2. If we're looking at our ratio, since it's always going to be proportionate, notice there's more pounds than kilograms. So your answer has to have more pounds than kilograms. So there's got to be more than 12. 12's on top. That's our kilograms. 1 goes into 12, 12 times, so times 12 times 12. If you type this in, 2.2 times 12 gives us 26.4. So if it weighed 12 kilograms, that means it would weigh 26.4 pounds. Last but not least, I'm going to do the first one for us, and then you're going to try 2 on your own. Ratios can also be solved from tables. So if you can't see it, I'm going to read it for you. It says, Marion attached buttons to a group of shirts. She attached 3 buttons to each shirt. Which table shows the relationship between shirts and buttons? Well, if each shirt had 3 buttons, that means there's always going to be more buttons than shirts, obviously. Because each one has 3, that means there's literally going to be 3 times as many buttons as shirts. So looking at all of these, there has to be 3 times as many buttons, which is on our right side, compared to the shirts on the left side. Well, 5 and 10, 5 times 2 is 10, so off the get-go, we know that we're not multiplying by 2, it's got to be 3 times as many, so this one doesn't work. 10 times 2, can't be it. B, 5 times 3 is 15, so far so good. 7 times 3 is not 18. 10 times 3 is not 21, so it can't be A or B. Looking at C, we have 5 and 15. 15 is 3 times more than 5, so 5 times 3 is 15. 7 times 3 is 21. 10 times 3 is 30, so this one is proportionate throughout. C is looking like the answer choice, but just to make sure, I'm going to look at it. There are more shirts than buttons over here, so I know off the get-go that D cannot be the answer. So the first one should be C. Based on that one, go ahead and try these on your own. Pause the video. Once you get both answers, unpause it, we'll go over it, and this will be the last slide we do together. Alright, we're going to do the top right one first. So it says, when Melanie downloads songs to her mobile device, she gets 4 songs per session. So that means there should always be 4 times as many songs as there are sessions. So we have 1 times 4 is 4, 4 times 4 is 16, 8 times 4 is 32. So then obviously it's going to stay the same, so you got to do 16 times 4. And when you type that in, or if you know already, 16 times 4 does give you 64. So that first one is D. Next one, when Cristobal views video blogs online, he views 7 blogs per session. So there's going to be always 7 times as many blogs as sessions. 1 times 7 is 7, 3 times 7 is 21, 6 times 7 is 42, so 15 times 7, when you work it out, 15 times 7 because there's 105, so it's going to be D again. That is it from this video. If anything didn't make sense, please go back and rewatch it. I don't know why I'm so out of breath, but hopefully you understand this a little more and you're good to go.